Hi, welcome back. We're going to pick up from section 6.2. This is our part 2 video, and we were working on part F. Okay, so we are doing our use substitutions given the problems on our notes. So let's pick back up with this one. So in part F, we have the integral of 1 over x plus 6 dx. So again, all we have is something in the denominator for u. So let u equal what's in the denominator. Take the derivative. So du equals derivative of x is 1, derivative of 6 is 0, and then we tack on that dx. Okay, you can put the 1 there, that's fine. Okay, does not matter. So there's our first two steps. Step 3, do the u substitution. So, okay, the 1 over x plus 6 is now 1 over u. And then we had the dx at the end, which is our du. Okay. All right, now we're going to integrate. And again, 1 over u, when we integrate that, that's a natural log. So the natural log of the absolute value of u plus c. And then we're going, that's absolute values. I know those sometimes get mixed up with what it looks like. So there's absolute value of u. All right, and then we're going to substitute back in what u is. So the natural log of the absolute value of x plus 6 plus c. Okay. So I hope you're getting the hang of that. That one was not too bad. All right, let's look at part G. All right, so we got a fraction. So again, we know that one of our choices for u is to let it be what the denominator is equal to. So let's do that. So our only choice for this one. And now we take that derivative. So du equals 3 times 4 is 12. Subtract 1 from your exponent. Minus 8 is the derivative of minus 8x. Derivative of 8 is 0. And that's times dx. All right, now let's look at our problem. Okay. All right. We have 12x cubed minus 8, but up here we have 3x to the third minus 2. So I have a common factor. So let's see. What can we factor out of that? Both of those numbers have a 4 that go into it, right? So if you factor out of 4 from 12, you get 3x cubed. And if you factor out of 4 from 8, you get 2. Okay, so we're getting there. So now I see that I have the 3x cubed minus 2 in the dx, but here's that constant, which it's okay. I'm just going to move it over to the other side because it's not in the problem. So we're going to divide both sides by 4. So now we have 1/4 du equals 3x cubed minus 2 dx. Now everything is okay. So now I can do my u substitution. So there was step 1, there was step 2. Here's what I've got to work with. So now I can do my subbing. All right, so the bottom is u, right? The bottom is u. And then this and this is 1/4 du. Okay, remember, I try to always keep the constants separate because those are going to come out front before you integrate. So bring the 1/4 out front. And you can do that all in one step, but it's typically what we do. Okay? All right, so now we're back to what we just did in the last problem. When we integrate, the antiderivative for 1 over u is the natural log. Okay, so now we're on step 4, and this would be the natural log of the absolute value of u plus c. Okay, and then substitute back in what u was. So 1/4 natural log, and u was absolute value 3x to the 4th minus 8x plus 8. There is your antiderivative. So, in some ways these are a little bit easier than what we did in section 6.1 because we're making these integration rules pretty darn straightforward, right? They're usually very simple. However, it does get confusing, and I do understand that we're actually finding a derivative first, and then we're going back and we're doing the antiderivative. So that is a little confusing, but again, you'll see that all of these, the same steps. So I'm hoping that these steps are helping you kind of see that, as long as you follow the rules and know what you're subbing in for, it should not be, too much trouble for you guys to do those. Okay? All right, let's try H. All right, so for H, we've got negative 5e to the 2x. So this one we haven't done yet, when our u value is actually going to be the exponent, because now the exponent is a function, okay? So we don't have parentheses, we don't have a denominator, so we have an exponent. So it's always going to be something that you can pretty much see and know what you're going to do with it, okay? So we're going to let u equal 2x. That's the exponent. So what is du? So du, derivative of 2x, is 2 dx. All right, so take a look at our problem. We have a negative 5 there that is nowhere here, so we got to get rid of this 2. So we're going to divide it over. So we actually have 1/2 du equals dx. Because remember, this constant and this constant are fine. They don't bother us if they're not the same. They're just going to get thrown into the pot when we multiply and find the antiderivative. All right, so step 3. Substitute in, do our u substitution. So the negative 5 is going to stay right where it is. E to the u, 2x was u, and then dx is 1/2 du. All right. All right, so we've got everything accounted for, so bring out the number. Constants go out front. Negative 5 times 1/2, that's negative 5 halves. We don't need to worry about that. It's going to stay part of our answer, e to the u du. So this is what we're integrating, and the derivative of e to the u, the antiderivative of e to the u is e to the u. So when we take our antiderivative, leave the constant, take the antiderivative, which is e to the u plus c. And lastly, we're going to substitute in for u. So our actual answer is negative 5/2 e to the 2x plus c. Okay, so that one wasn't too bad. That was the first one we had the exponent though, but same rules apply. Okay, all right, part F, x times e to the 3x squared. All right, again, no parentheses, no denominator, so we are going to let u equal the exponent, 3x squared. Okay, so the derivative du is going to be 6x. That's the derivative of 3x squared dx. Okay, all right, I don't see a 6 out here, so I need to move that 6 out of the way. So divide both sides by 6. So we get 1/6 du equals x dx. I have the x dx. I have the exponent is u, so everything's accounted for. This is just going to get tacked on as that constant. So when we do our u substitution, okay, e to the u, the x dx is right here. So x dx is right here, which is 1/6 du. And the e was there, and I substituted in u for u 3x squared. So that's everything. Okay, so we're going to bring the 1/6 out front before we integrate. So now it looks kind of like the last problem. All right, so let's do our integration. So leave the 1/6 there. The antiderivative of e to the u is e to the u plus c. And then just substitute back in what we did for u. So 1/6 e to the 3x squared plus c. So some of these are pretty quick. Okay. And what I think for most of you guys, once you get through this part, when you don't have everything accounted for, or when the constant's different, but as long as you see that, the rest of it's pretty straightforward. Okay, we'll just keep practicing on it. All right, last page, 2 more problems. All right, so J. So we have parentheses, so that's where we're going. Okay, so we're going to let u equal 2 minus 3e to the 2t. Now, you might say, why didn't I let it be the exponent? But again, you want it to be the harder thing. So typically the parentheses are going to rule out because they are going to kind of be the first thing you're always looking for. That's the hardest thing looks like in here. Plus we got to do the derivative and make sure that's in the problem as well. Okay? All right, so let's do our derivative. So the derivative of 2 is 0, so we don't need that. The derivative of negative 3e to the 2t is negative 3e to the 2t times the derivative of the exponent times 2 dt. Okay? So du is actually equal to negative 6e to the 2t dt. Okay? Remember, when you take the derivative of e to the anything, it's e to the anything, then times the derivative of the exponent. So the derivative of 2t was t. And that constant just stays part of the problem. Okay, so look at what we have for our derivative. Negative 6e to the 2t. And out here we have negative 5e to the 2t. Constants don't matter, but if they're not the same, get rid of that. So we're going to divide both sides by negative 6. So we have negative 1/6 du equals e to the 2t dt. Okay, you just want what's over here, what's in the problem. Constants don't matter. All right, so now I'm ready to do my use substitution. Okay. All right, so the negative 5 is going to stay. Didn't have that. E to the 2t dt, that's going to come at the end. So now I'm going to look at what u was. So I've got u to the third power. Okay. And then e to the 2t dt here and here, that's this. So times negative 1/6 times du. Okay, so everything's going in there. Now we're going to simplify and bring that constant out front. So you got negative 5 times a negative 1/6. That's a positive 5/6 u to the third du. Okay, so that's what we're going to integrate in step 4. So leave the 5/6 there. Remember, you're going to add 1 and put it over that number. So u to the 4th over 4 plus c. Okay, so I added 1 and I put it over that number. All right, so what does that give us? 5/6 times 4 in the bottom, 6 times 4, so that's 5 over 24 u to the 4th plus c. And then step 5 is just substitute back in what u was. So u was 2 minus 3e to the 2t to the 4th plus c. Okay. All right. Last problem. Now it looks hard, but hopefully after all we've done, you know exactly what to do. All right, so let's look at part K. We have a fraction, okay? We do have an exponent, but we have a denominator. Remember, parentheses and denominators come first, and typically the harder of the two. Because when we take the derivative of this, we'll get that. So we always want the derivative in the problem, okay? So that's why typically it's the denominator in the parentheses. But again, if you have a denominator and an exponent, it's still going to be the bigger of the two or the harder looking thing. So let u be the denominator. And then we're going to take the derivative of that. So the derivative of e to the negative 6x is e to the negative 6x times the derivative of the exponent, which would be negative 6 dx. So that's going to give you, if I clean that up, negative 6 e to the negative 6 dx. All right, so again, look at my numerator. I have a negative 4 instead of a negative 6, but I do have e to the negative 6x dx, so I just need to move this over to the other side. So divide by 6, so negative 1/6 du equals e to the negative 6 dx. Okay, so again, I just divided both sides by negative 6. Okay, all right. So now we can do our, didn't put my steps. So there's step 1, step 2. So now we're on step 3 to do our u substitution. Okay, so the -4 is going to stay right there. Okay. All right, in the bottom is our u. And then e to the -6x dx is -1/6 du. So there's everything accounted for. Okay, so our constant is -4 times -1/6. That's +4/6. So I'm going to bring that out front and reduce it. 4/6 is 2/3. So that just leaves me what I need to take the integral of. Right, so negative times negative is positive. This is 4/6. So if we reduce 4/6, you get 2/3. Okay, here's our good old integral of natural log, right? 1 over u when we integrate that. So step 4 is natural log of the absolute value of u plus c. And then step 5 is to sub in what u was. So 2/3 times the natural log of the absolute value of e to the -6x plus 6 plus c. Okay, so there's your answer for the last problem. All right. So that is called integration by substitution, otherwise known as u sub, because that's what we're using, always u. So that's just the typical letter for these that all of your calculus books will use. So that's what we will use. All right, so that should be plenty to get you through your homework. If you need any extra help, please let me know or go to tutoring. But go ahead and start your homework as soon as possible so you can keep practicing.